Hello everyone, welcome to our new series. In this series, we will forensicate a malware sample and show you how you can use the set of tools that you have seen in our previous demo. If you haven't watched that out, please check it and prepare your lab. You will find the link in the description box below. We are going to cover the below pointers in this demo. First, we will create a fake DNS and other required services in INETSim. Second, we will configure the host to make our environment safe and secure. And then, static analysis followed by dynamic analysis of the captured malware. If you have any query, please let us know in the comment section below. Before we begin, please subscribe to our channel so that you get more such interesting topics on DFIR.
Okay, so we are beginning with our virtual machines right now. So what we will do, Windows 7, this virtual machine, uh, let me, before powering on, just let me tell you the network configuration, what you need to do. Windows 7, this machine will be your malware machine or infected machine as such, and we will be performing overall action, what have we need to do, and what sort of action, everything on Windows 7. So the configuration, if we just come here and if we check, so the network adapter, so we just need to make sure that the network adapter is VMnet 1, so and host only mode. So VMnet 1 is the default network adapter for VMware, and we are making use of it in the sake of this demo, and for the reason that nothing just pops up from your virtual machine and can infect your base machine, right? So and we will use the 1 second, so let me just power it. Before powering it on, one more thing that we will be using, we will use remnex 6.0. So why we need remnex? So I haven't told you about the remnex in our previous video where we are preparing the lab session, because there is a reason. Remnex we have told about a little bit, where you can download the demo, the virtual machine image in our another video where we have given the malware analysis, code debug, and code deobfuscation for malicious JavaScript sample. So we have given those information in that video. So I'll paste the link in the description. You can go and check that out. And Remnex will also be in VMnet 1, the same network configuration on which our Windows 7 host is right now. So let me power it on my both virtual machine. So what I'm gonna do, the Remnex 6.0, this virtual machine is specifically we will be using for INETSim service. So that is the reason we will be using this Remnex box. So what is INETSim? So um, your malware need to communicate with at times your malware need to communicate with some internet sites, right? Now if we allow the internet connection, so probably if we are analyzing any kind of like ransomware or something, so that can really infect or damage my virtual machine environment, right? So if we establish the full set of communication, so that is a big caveat on that. And if you make your network connection, if you just disable your network connection, so that also not gonna work, because some really cool malware features and some really functional malwares are as such, so they don't replicate themselves well in a virtual box environment, and when they see that okay, my connection is not going anywhere, and it is getting dropped, so they generally don't execute properly in that virtual machine. So that also doesn't solve our purpose. So we cannot just simply uh, turn off the network communication. So what we are gonna do, we are gonna fake the DNS survey. So to do that, as we have shown, so both of my VMs are right now in same VMnet network configuration. So let me check my um, IP config of Remnex. So the IP address of my Remnex system is 120, 198, 168, 129. And if I go here and uh, check the same, so it should be in the same subnet. Just let us check, do a quick check. If config, sorry. Yeah, so you can see it is 128 and our Remnex is running 129, I guess. Yes, correct. Right. So we can just check if both of our virtual machine is talking to with each other or not. So we just simply do a ping and check it. So let me do a quick ping here. Uh, Paste it. And as you can see, I am getting the reply from my Remnex virtual box, right? So both of my machine is working perfectly and the network communication has been established right now. So what I'm gonna do right now, let me show you the INET SIM, what actually it does. Um, so INETSim is a special kind of service. You can Google it as well. So in Remnex platform, INETSim is already installed by default. So you do not need to install it again. You can just do a sudo, just update your system, and INETSim will be updated anyway. So before you launch INETSim, so you need to open this configuration file which resides in your ATC INETSim, and you can choose any of your editor of your preference. So you can use Vim, you can use like VI editor, any other. So I am using gedit. So what we will do now, so just let me do a full screen here. Okay, so what it does basically, so when you open this configuration file first time, so you will see all these service will be marked before like hash. So there will be a hash before all these services. So um, you need to remove those hash symbols from this configuration file. So that means you want, when you are running the INETSim service, so all of your these packets like a DNS service, HTTP, HTTPS, SMTP, all these in the listed will be running on INETSim. So if anyone is communicating with your Remnex IP address as a DNS resolver, so that will fake the IP DNS address, and that will tell you that yes, my DNS is getting resolved, right? So the network communication is established in that way. So we are faking the DNS, right? So rather than reaching out to Google or anything, so we are just opening our own service here and we are running it over here, right? So first step, what you need to do, first you need to remove the hashes from this all services, which will be default in the first time service. And next thing, this service bind address. So make sure this address is the same address on which your Remnex system is running. So I showed you, right? So my Remnex is running on this 129 IP address. So if your Remnex is running on something else, some other IP address, so you can mention it over here. So that is the binding address. And one more thing you need to do, so you just need to do here and write DNS. If we search here DNS, so this one, DNS default IP address, so that also you need to mention the same IP address of your Remnex host, right? So these two configuration you need to make sure that your machine is properly done before running the INET service. Okay, so I'll press Ctrl S for saving this and I will close the window. Okay, and one more setting that you need to perform on your Windows machine. So that is, so let me show it. Open Network Sharing Center, local area connection, properties, and IPv4. This one. So by default, this option will be like this. Okay, obtain DNS server address automatically. So if you select this one and just let me clear it up. Okay, CLS maybe. Yeah. Okay, so if you do a NS lookup, suppose google.com, so that won't get resolved, right? So you can see, um, so request timeout, right? Okay, so this is taking anyway the IP address of my Remnex host because of the reason that I have pre-configured it like that way. So just let me close this window and let me try it out again. Um, Okay, as you can see, so this will be your first IP address if you haven't configured your DNS to Remnex box. Okay, so this will be your default address for DNS in here in this in the Windows system. Now you need to go back and you need to do IPv4 and you need to come here and you need to mention the same IP address 168. Okay, what was that? 168, 184, 129. Okay, 184, 124. Sorry, one, right? Is it correct? Oh, sorry. Uh, I'm really poor memorizing my memory. 129. Right, so this is my Remnix IP address, and I am using this IP address as my DNS server. Okay, so all set. Close. So what I will do now, I will start my uh, Remnex service now. So sudo INETSim. So to starting off your INETSim service, you will need to mention sudo INET service. Okay, so as you can see, DNS, TCP, all these are started and PID is also showing now and the simulation is currently running, right? So there is nothing much you need to do on your Remnex. Just you need to keep on running this service. So that's all. And now if you go back to your Windows box and if you do a quick check and you do a quick check for let's say ns lookup google.com. Yeah, so you can see we are getting the successful connection you as per se, but the IP address is always resolving to our Remnex host. So if you do the same for like Cisco, same, so you can check like that way. So like Gmail, same. So all the time, so if our Windows box is trying to reach any of the let per se like any of internet connection, um, it will resolve properly, but it will fake the DNS since we are routed our traffic to Remnex, right? So that's all from setting up your lab. Um, we won't do anything much on Remnex, so that just we need to keep on running and background. So now the actual test begins. So what we will do right now, so we have captured one particular malicious file as per se, malicious sample in our system. So we are going to analyze that. So what I will do, I will just paste it here, and I'll close it off, and I will extract it, extract all. Okay, so I don't need another folder. I can extract it simply. Okay, so you can see WOT super is our malicious sample that we are going to analyze in this lab, right? So before starting, so I hope you have already watched our first part of this video. So where we have shown what are the tools that we are gonna need to perform this lab. So a small checkup that we need to perform before we start. So to run procdot properly, procdot basically requires a third-party component. So if you open procdot, you can see a text box appearing like an option. Procdot depends on third-party component. So what you need to do, this .exe, so this is another like software or application per se, GraphViz that you call it. So we can just download it from internet, and where the GraphViz is showing, it is installed basically the .exe. You just need to mention the path over here, right? So that is another prerequisite for procdot to run properly. Okay. So we'll close off, and we will be coming up that very shortly in procdot, right? Okay, so first step, what we need to do. So first, okay, malware sample. Okay, so Regshot. We have told you about the Regshot tool, right? So what we are gonna do this time, Unicode and see any of you can maybe you can select. So for this in particular demo, we are going to start off Unicode. Okay, unicode.exe. It so what actually we are doing now, we are taking a snapshot of the fresh uh, lab system before running the malware. So what we will do, we will scan the directory as well. We will scan it for the C drive, and the output path anyway it will store. So you can store the output as well if you just come here, and if you just click here. Uh, it will give you the short, you if you want to short and save and load. So any option you can select, but for this demo we just need to take the short. So that's all. So what we will do, it will check all the files, and it will make a log entry, and the files under the C colon and the registry key as well. So let's run it. So we will give it a little bit of time till this shot gets completed. So once it's get completed, this second short window will populate. As you see, it's done. Okay, so we will minimize this window, um, and the shot has been taken. Okay, so what we will do now, first we will load our PEStudio for running our um, static analysis, and this WOT super, we will simply drag it in this particular application. Okay, so it is being populated. So whatever this particular malware sample as per se, PEStudio will give you a lot of information what it can achieve from the static property, right? So the SHA value, you can see the hash value has already been populated. So if you start from that area, so these indicators, virus total, some portions and some APIs will be not running because we haven't actually enabled our internet communication. We are faking the internet service, and we are telling the malware that okay, the machine is actually having an internet access, but that is not right. So we are faking that actual communication through our remnext box and INETSim service. Okay, so if you come here, if you just do a quick check, you can check this particular SHA value as well. So if you do a like simply copy lines, or you can search in VirusTotal directly. So I'll do a copy line and I'll come back to my base machine, and what I will do, I don't need this thing. So what I will do, I will check in VirusTotal. So these are the practical, like static analysis that you can run, right? So we do a notepad, we just simply paste this file here. So it will, as you can see, it is giving me already the information from this hash value itself. So at times when you are doing incident response, you might not need to run a full analysis on it. So you can check it from VirusTotal itself, and you can find out if anyone has done previous analysis. But we are going to deep dive on the analysis, so that's for just the sake of the return. Okay, so next thing, the hex index. So as you can see, the first byte text. So from the look of this information, this file looks to be something packed. Okay, so how we can say that? So if you come here in this library information, so the basically, if there is any exe file, so that should have the DLL, so more of the DLL, so dynamic link library. Obviously you are aware of it. So so if a particular exe file needs to run, it should have a lot of DLL files. So but we are not seeing much of DLL files, only kernel 32, user 32, um, then Ole DLL, Ole32.dll, shell 32, and 2. So, and from the PEStudio standpoint, so it is already stating me these two DLL files are probably blacklisted. And so description, what it says, Windows cabinet file API, okay, quite interesting, but that shouldn't be a blacklisted file, right? So it should be a legitimate Microsoft cabinet API file per se, okay. So that is the first indicator of my understanding that, okay, so this might be a packed file. Now if you come here and if you import, okay, so this is a quite interesting information at your hand, okay. So so this color coding is stating is, so you can come back and you can check, so there are a lot of color codings for groups perspective. So what actually, when you will be running this particular application, it will import these all of your um, package as per say into your memory, and it will load that into your memory. So if you come here and if you see virtual alloc, virtual free, local free, and local alloc, so these most of the properties as per se, so these are not actually properties, but for sake of understanding, let's say the properties. So it will try to inject some memory in your system's application level, okay, and it will try to run kernel 32 DLL, okay. So that means when you run that particular process, it is packed first of all, but after running, it will start to populating and start preparing for more memory. So that is another indicator that, okay, there might be something really fishy going on. And as you can see, so this some of this particular as per say the application which it will be importing is blacklisted. Okay, so that is another big IOC that we are going to say, okay, this is another system or another indicator that this is a suspicious file. Okay, now if you go to come here and if you just check the strings, so strings is something like PEStudio will tell you what are the string that it can find from this code perspective on this particular malware, which might be suspicious. Okay, so first thing, it got wtsuper.com. So this is a blacklisted domain. So already we know the file name is WT Super. So not much of interest for me. So might be the file has come from this WT Super website. But the second thing, so there are a lot of WT Super exe, WT1 exe, WT Super reg, uninstall exe. So this probably I am thinking in like that way, this exe will be dropped at some point of time into your machine if you run this particular software. Okay. Next thing, https ip logger org dot html. So this is looking for me another indicator of compromise. So if I copy the value, and if I paste it here. Okay, so let me do a quick check on VirusTotal, what VirusTotal has to say about this file. Sorry, this domain. Okay, so I'll do a URL, I'll do a quick scan. Okay, so it is telling me, okay, it might be malicious, not a big score, but still worth of validating, right? Okay, so if you like that, if you check, so regedit.exe is also another thing that it will try to maybe import. And if you can see, there are a lot of blacklisted thing is happening, and there are a lot of blacklisted value. The string match, it is present in the binary code of that particular file. Okay, so there are a lot actually, right? So if you just do a quick short, and if you can see, all these binaries and strings are looking suspicious. Okay, so this is another indicator. Now this is a manifest file. So what does it mean? So when you probably see the binary level modification of that file, it has an administrator template stored inside it. Okay, so and it is in XML format. If you just do a quick check, and if you check, it is telling require administrator. Okay, so Microsoft Windows command controls, and it requires administrator privilege. So that means it will try to escalate the privilege if you are already admin of the system. Okay, so this is the manifest template of this particular file. Okay, so there are some other interesting stuffs already there. So if you come here, and it will give you the same DOS, what are the information present in here. Directories, if you can say, so probably these are the directories and location of the file where it might store something after execution of that file. So library already we told. So as of now, we have gathered um, some interesting information, right? So if you come here, and if you check this indicator, so that is another big thing for me, or at least for incident responder. So what it says, the file contains another file type smart installer overlay, something like that. All right, so we have already seen this in import section, isn't it? So where we are going this import section, and the strings as well. So we have seen the same file like wt super 1 dot something. So those are getting dropped. So that means what it's trying to do, it will load into your memory, it will capture the or it will span up into your memory. Basically it will get unpacked, and it will load another, and it will drop another installer into your machine. Okay, so this same URL we have seen in the string match as well. Okay, this as well. So severity 1 means high. As you can see, it is marked in red color. Okay, so quite an interesting information from static analysis already. Okay, now you can jot down all of your points. So just remember, malware analysis is like the kind of theory thing, and as much as you can grow on it, you document the thing, you document probably the identification, you get more juicy information, and you can get back, and you can come back probably, and you can correlate. Okay, so next thing, what we will now we are in such a point of time, we will run this installer file, and we will see what is basically happening. Okay, so for doing that, first we will load up WireShark for our capturing the traffic. Okay, local area connection, that is the thing that we need to capture. And as of now, we will stop it when we are setting it up. So when we run that, before running that, we will enable the every option. Okay, so we don't need the control panel, we will close it off. And one thing that we will first off we need to do, we will run process explorer, okay, or process execution, whatever reference thing that you can say. We have already told about this tool in the previous demo. Okay, so this tool will give us the hint if after running this particular installer, if something else is popping up, or like that way, something else is firing or some other exe is getting injected, like that way it will give us the information. So you can see WireShark, if we have run it, so it is giving us those exe file information. Okay, so one more interesting thing we will load up, procmon as well. Okay, so we will run it as administrator. Okay, and we will minimize it, and we will as of now we will stop the capture, and we will clear it up, and we will start the capture just before we run the malware. Okay, so before we start running the malware, one common and some interesting thing that you need to remember to for the next level of graphical representation of your data, what actually went wrong, what else might be you got into your machine. So one thing you need to check here, first you need to come to option, and you need to take it off. So show resolve network address, we do not need this option, we will tick it off, we will check it, it is gone now. And one thing, we will come here in select columns, and we will check this thread id, we need this, we will tick it, and we will see that the sequence number, we need to make sure it is not ticked. Okay, so these two, and one more thing, we will come up in filter, and we will see that this enable advanced output mode should be unchecked. So by default anyway it is unchecked, but you need to double check before loading the malware. So if you do some kind of mistake or anything, so might be you can have trouble to dot or map your data rather like next point of time in your proc dot software. Okay, so now we are almost ready with for running this malware. So let's first kick off our WireShark, capture, continue without saving, capture started, and this thing is also we are starting now, and we will run this off. Okay, run as administrator. Okay, okay, you can see lot of chrome.exe, something is happening. Okay. Oh my God. DLL super has stopped working. Check online solution. Okay. Quite interesting. So it crashed already. Okay. Never mind. So it tried to load a file as well. IP logger. So you remember this particular HTML or this host name we found in from static analysis already. Okay. So, okay, we will close the program, and we will close it off as well. So, okay, lot of thing is happening. The red color sections is telling me they have launched a lot of things, but I think it's quite obvious now. So, WT is super. So you can see. So this is another thing might be launched. Okay. So what I will do now, let me give a little bit of time, maybe 30 seconds of time to run the malware, and it will anyway try to do the same thing again and again. Uh, uh, it's now, I believe it's enough time for the malware to execute in the system. So what I'll do, I'll come here and I will simply press this capture off. Okay, so and I will kill this process as well. So I believe you remember this process from static analysis. I will close it off. Okay, anything else I need to check here? I don't believe so. Okay, so I will close it off. So now what I need to do, uh, I need to take a dump of this total data what has been captured by Procmon. Okay, so what I will do, uh, I will come here and I will save this, and for the interest I need all events. Okay, so just remember, for mapping it in proc dot, we need CSV format. Okay, so we select CSV, and we might select desktop. So log file uh, analysis. Okay, so we will select as CSV and we will save it. Okay, and we will click OK. So it will, maybe it will take already it's saved. So I'll minimize this option, and I will now load a second shot of Regshot as well. So let it run. Okay, so my shot is running now. So what I am trying to check, what are the modification might be done by this malware before my machine was fresh. Okay, now what I will do, I will compare the both shots. Okay, so I'll compare it off, and it will give me like quick output of the interest. So as of now, for this I'll minimize it and I'll come back to that later. I'll minimize it off as well. So what we need now, our log file is stored for procmon, and I will load proc dot. Okay, yes, I need full permission on proc dot. Okay, so the execution path has already set to .exe, as I told you for starting up this course, and I will load the procmon file what I have just stored here. Okay, so log file analysis, log file test, so both are the same file. So anyway, I am going to load this test file. Both are the same file. I am going to open it. Okay, so what I need to do now, so you see this little ellipsis option on the launcher. So I'll hit that, and what procdot will do, procdot will try to analyze the process execution what has been done after we launch the malware. Okay, and it will give you the option to which you need to select as root to map your graphical representation. Okay, so let it give a little bit of time till it gets loaded. Okay, so I'm guessing the probably the data could be some MBs. So just check it out. What could be the data? Properties. 114 MB. So it's a quite big data. Okay, so proc dot might take some time to analyze the data. Okay, so we'll just sit back and just let it run. Okay, it's almost done. Yeah, so you can see in that small interval of time there are a lot of execution has happened. Okay, so what is our patient 0? So we know uh, this looks like our file, and this also looks like our file. Okay, so we, and also wtsuper.exe, this also looks like our file. So any of the file name that might have come up and spawn up the other processes. Okay, so we do not know which are the first in occurrence. So let's say we start with this only. So we will click on this, but we can check the PID which is the lowest PID. Okay, so we will click on this one. Okay, so this is loaded into the launcher, And what we will do, we will compress it, and we don't need the path as well. Okay, so we will refresh it. Okay, now proc.dot will try to represent what data, what went as per like when you launch it, and it will give you a graphical representation. Okay, so it will create an interactive graph. Let's just wait for a minute to launch it. Okay, so as you see, my graph is loaded now, and it is like full of data. Okay, so I will do maybe so it's like full of gibberish data. So what I will do, I will try to um, do a little bit of zoom in so you can see. Okay, preset view, so zoom in, then graph, again zoom in, view graph, again zoom in. Okay, so you can just like that way also you can do. Okay, so what is our starting point? So this is our starting point. WOT super is what is our first execution that we ran on this machine. What it did, so if we zoom in a little bit more, so what it did is has created a thread with this process ID. It went back, it created another thread, created this process ID, and this process ID has created a child process with the same name. Okay, and it has created another child process with this uh, so I believe this is a registry. So let us check, and what is it, details. Okay, so it is storing in Windows WT super.reg, C super.reg. Okay, so we can check here, we can view the data, but we will do that later. But we know, right? So it has created another file, and so we will click back, and what else it did? So it did a lot of things, right? So um, okay, so it has created a temp file. Okay, so what if anything is stored inside? So we can go back and check the details. So first create time, upload data. Okay, it is doing something. So we might be interested for capturing all these uh, you know uh, all these temp files when the particular thing is running. So as you can see, so what it did, so let me little bit zoom. So these sections, so what are the purple lines, it's giving that it created a file. Okay, and it deleted a file 2.temp, and what are the red line is telling me, if I zoom in a little bit. Okay, 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 so somehow or related, what it was doing, it our main process has created 2.temp, and afterward it deleted that file as well. Okay, and it might be okay, it has stored some variable inside this instance. So let's check what is this. Okay, so it is also in the temp folder. So lot of things has been happening inside the temp, right? So if you see here, so so our main file has created a process, child process as per se, and it has created a regedit.exe file. Okay, then it has created another thread. So what is this file happening? So details. Okay, now interesting. So this is the full path, regedit.exe, and command line. So Windows regedit.exe is calling wtsuper.reg. So this is quite interesting, isn't it? So what we will do, So we will just little bit zoom out so we can check the other components as well. So we have checked the overall the upper section. So we are now interested to check if any um, so we got it already. Okay, so what it did, it this particular second exe that was spawned from the first one has made a HTTP connection to this IP address. Okay, and it got a response as well. Okay, and this is another thread that was created from the same thread ID created, if you can see, created process and created another thread, and it tried to communicate another IP address. So if you just check, um, so add filter, follow recipe stream, extract files from flow. So we do not need this all of the information as of now. So this is the IP address. So what we didn't do in this demo, so we have captured the WireShark as well, right? Okay, I forgot to stop it. Okay, anyway, so what we will do, we can check back and we can search it for this IP address. Okay, so let us so the details. Okay, copy cell, copy line, copy column, copy cell to clipboard. It is copied. So what I will do, come back and I will try to filter out this from WireShark. Okay. So IP address is this. Okay, so WireShark is not having anything anyway, but I am not bothered in that. Probably the time when we launched WireShark, it didn't capture it in that way. But anyway, so we got another indicator of compromise, and if we just come here and check what is this IP address. Okay, so it is telling it's a spam. We can do a deep dive on this IP address as well. Um, so let's go back and check what else it did. Okay, so this particular section might be when we killed that WT super 1.exe from our process explorer. Okay, it has created a file. Interesting. HTML file it has created. Let's see. Details. Name HTML file level. No, okay. No information is other than that. Okay, so lot of things are there in this file and in this malware. So okay, so you got another set of compromise. So what it did, so this child process, so first it was our main, it created a child process and this child process has created another execution. Okay, what is its name? At times it might be a little bit tricky to check all of your um communication through this navigation panel, but at least if you want to really deep dive on and check what the things went wrong, so this is your best friend. So you remember a lot of chrome.exe was popping up into your process explorer. So these are all of these things. Okay, iplogger.org. Okay, so what it did, so when you go back and if you check chrome.exe in this file, okay, so we are just copy the cell to clipboard, uh, okay, copy it, okay. So what we will do for this demo purpose, we will check back uh, the uh, the level of the static property of this chrome.exe, okay. So it is launching this particular site iplogger dot this one. So you remember we have a site opened in our browser. We never didn't open it, but after loading the malware, it suddenly opened up. Okay. So basically, a lot of information you can gather from this, graph information. So I'm not going to check all of it. Otherwise, maybe it will take a whole day just for me to analyze this data anyway. Um, but I believe you got a little bit of idea what actually has happened on this, and what the malware has run, and how you can check these things from the proc dot. Okay, so what the another feature of proc dot, okay, where is the graph? Okay, so this might be another problem for having a low rate of RAM. So make sure when you are doing a malware analysis, at least your RAM should have a 4 GB. Your VM should have a 4 GB RAM. Okay, so we will close it off. So we got pretty much information, and you can prepare your incident report out of it, right? So you already know what went wrong. Um, what are the things that so what happened, right? So you know some stuff and some basic information, right? So you can prepare your incident report from it. And if you just like, if you check here, so um, okay, certified. So this particular frame, it gives you the, if you run an animation on it, so this is the full picture, right? So if you little scroll in, okay, so my RAM is not supporting it. Okay, anyway, I stop it, and I'm just trying to show you how the um, animation set works here. Okay, okay, so I'll stop this one. Okay, so I'll try to zoom in a little bit from maybe here only. You graph, zoom in, okay, come here. Okay, view graph again, then zoom in. Okay, now I can do okay. Yeah, it is now up. So if I try to um, come here and I try to do this button like toggles between the frames. Okay, so if you uh, just do a next, so it will show you what happened to your system probably in the next phase. Okay, so this means, so it toggles me the next frame what has happened. So already you know this is the next, and next it created a temp file. Okay, so if you go and go back, stop animation, if you start animation, if you see, right, so it started and it killed. Okay, so it created this one. So it was talking to this, right? So what it did, it created this one. Okay, so if I just little bit scroll down, okay, so it next, so like that way you can see what are the events that occurred, um, as a statistical manner and in the frame information. Okay, so at your convenience and at your point of time, you can stop the animation, and you can like keep on running it, so you will understand the full work chain of the flow. Okay, 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 so you were saying it, right? So you got the idea how the animation is also work. So this is a super tool, so with the scope of this demo purpose, we do not have much time at our hand. But like the way, if you run the animation, you will have a lot of things happening, and it will literally tell you what went wrong and after what actually happened. Okay, so I'll stop the animation. So I'll close it off. So what I will do now, I do not need to save it. So I'll now go back and I will check back my Regshot. Okay. So what it did. So keys deleted. These two keys got deleted. So your okay. So this might be so. the key deletion and addition from your perspective, like your system whenever is talking to someone or doing something in background, it keeps on deleting keys or adding keys, right? So we might not be interested so much on key deletion if we see any legitimate process, but key addition, if you see, like, so wt super, all this addition and key addition has been added. Okay, now uninstall this. So that means this particular instance, after running your malware, so all of this information has been added to your registry key. So seems like it is trying to maintain a window, or it is trying to maintain a persistence through your memory. Okay, now if we come back, so there are a lot of value addition happened. uh, okay, uninstall.exe, help link. Okay, so lot of things has happened. Okay, so we will come back and we will check value modified. So these are all registry values, right? So we are trying to check, yeah, these thing. So 37 file has been added by your malware. So isn't it interesting? So a lot of file, right? So and it deleted some file as well. It modified some files. So for starting up with your so it added a folders as well. So this is a juicy juicy information that you can um, you know attribute from Regshot. So now if you go back, so for sake of example, let me client manifest.txt. Okay, okay, so these are quite interesting things that is happening right now. Okay, WireShark. So this is my WireShark file, log file analysis, or nothing, wt super dot rage. Okay, so lot of file has been dropped on your machine when you run. Now you can check each and individual file and prepare a full template and full report as per your need and your organization need. So just for the sake of the tutorial, let's see and check what is calling. Okay, we will minimize it and we will now launch up our agent ransack. Okay, so what we are is our target. Okay, so we are trying to search this manifest.txt under C colon. Okay, so what was the log? So it is not in C drive. So where was it? See all user. So it should be there, isn't it? Okay, if ransack is not giving it, so we can do another thing. We can check back, we can load the run and we can come back here. Continue. I have permission. I am the administrator of the system. I can open it. Okay, so it looks like it has dropped a kind of a manifest file that we have seen from the static analysis as well, right? You remember. Um, okay, so you can check back. So there is a dat file as well. So let us check uh, internet. So this is, I believe, this is from temp data. So I'm not sure if we found it or not. So we'll copy it and we'll try to check it again from run. Let's see. Okay, yes. That file. Let me open up if I am able to open it. Why open it not? Okay, never mind. So I'll close it off. I don't need ransack as of now. What I will do, I'll launch up PEStudio and I will drag this file off. Hmm. So very less information. Okay. So might be now again like that way you can do a quick roundup checkup and um, you probably do a full analysis on your machine to understand like what are the files what got dropped, but by now you already know the full step of analysis what actually went wrong, what the files has been modified, right? So for this demo we will show you the last step. Now we are going to capture the memory of the file. Okay, so what we will gonna do now, uh, don't split. Okay, so we will browse it off and desktop. So we can store it in raw. So we will write up as memory. Okay, and we will put a simply save and we'll start the capture. So what it is doing, it is storing my volatile memory. So probably in the next demo we will come up and we will show you how you can forensically analyze these malicious or infected host as such. Okay, so RAM successfully saved now, so no further information is required. Now you can simply drag and drop this file and you can take it to your shift workstation and you can analyze it from volatility. Okay, so like that way you need to start off your forensic information and investigation and to kick off your malware analysis. Okay, if you have any query you can post us in the comment section below. So we will be happy to help you, and for this particular demo purpose we are keeping OLE debug out of the scope because that is really a advanced level of debugging a particular file or reverse engineering that file. Okay, so so much we have covered almost all of the points. So the last thing that we want to show you how you can analyze the files from the packet capture as well. So you have seen Regshot output, you have seen the Procmon output as well. So what the packet capture has been done. So if you just filter the, if you just apply the filter on your DNS traffic, so in the interval when so really nothing was running, right, when we have just triggered that the application, the malicious application. So you can check back what are the files and what are the DNS communication it has made. Okay, so this is the first interesting point. So if you just trace it and if you check, um, so this is something like japanwenran.com. Okay, so if you come here and if you check, okay, so you can check. So this is your another IOC. So you can check back. So let me just do a copy, uh, field name, and what I am gonna do, I'm gonna check it. So already I have did a quick check on virus total, and as you can see, this is a malicious domain. Okay, so this is your another IOC, and if you come back and second DNS request to the same domain, so this was our remnex host. This is already we have seen, right, from the every point of view, from static analysis, from dynamic analysis in like the process monitor, like that way. The third, the accounts.google.com. So it might be general query when the Google Chrome was launched. uh, this is the same thing, client Google Epics. Okay, so this is looking an interesting thing. So uh, let us do a quick check on this as well. So follow the stream and we will come here and we will check what is its meaning. So we will copy it as well. So value we don't only need, so we'll come here and we will check this. So we will remove this and we will check if something is there. Okay, so there is nothing. So obviously local domain won't give us anything because but what we can do, let us go back here and let us check it here. Remove the local domain and we will PEStudio.com. Let the scan run for a while. So it is saying it's safe, but the file, okay, the file looks to be malicious. The domain name itself looking malicious, right? So you can follow the stream. So this is your probably your another set of IOCs. Okay, so if you come here, this is another one. This is another one. So it is quietly looking like um, suspicious domain, and it is looking like it got created by some uh, random algorithm. What we say, spoof domain. You can check it out as well. So we'll copy it. Okay, so just first follow the stream. Okay, if you come here, if you just do a local domain, if you copy it, okay, copy the value. So it looks like a DGA domain, I believe. So XY, XZY, file go. I am not sure if it is a legitimate domain, but it looks like a DGA to me. So we can do a quick check. So if we check here and if we come back and do a quick analysis on it, .com, might be virus total doesn't have anything, but let's run the search for a little bit of time. So meanwhile, okay, details. Final, it's nothing. So if I try to resolve this, is it getting resolved? Okay. Hmm. So you can check back the resolving IP address. You can simply run a NS lookup and you can check it out. Okay, so it looks like DGA to me, domain generation algorithm, but like that way you can trace back. Okay, so you got your another set of IOCs. Okay, so from the packet capture as well. Okay, so we'll quit the saving. So most of the things we have covered now. So I believe you can now start your own malware analysis as well. Okay, so another the last topic, and the probably this is the most important question every incident responder might have. Um, so what are the what site they can visit? So URL host is a really good site where you can download your malware sample. So I'll post the link in the description box below, so you can follow that. And if you come here and if you just check for exe, so you will get a lot of exe file, and you can probably download into your system, but make sure this file doesn't get downloaded into your own machine rather than in a controlled environment, so that that doesn't come out and pop out into your own machine and infect that as well. So that would be a nightmare and disaster for you, but this is a good repository from where you can download malware, and you can only use it for debugging and upskilling your technical knowledge on that area.
We hope this has been informative to you. If you like the content, please give us a thumbs up and subscribe to our channel. You need to also hit the bell icon so that you get notified as soon as we upload new videos. If you have any query, please let us know in the comment section below. We will be happy to help you. Thanks for watching.